Math 1314, Tyler Junior College, Section 1.7, Linear and Absolute Value Inequalities. Solving Linear Inequalities, Part 1. Okay, let's start solving some linear inequalities. Just a reminder, the word linear in an algebra context means degree 1. And what that means is the highest power on your variable is 1. So for linear inequalities, we won't see any squares. That'll happen later. So let's start with 7x plus 1 is less than or equal to negative 10. And I should mention that we're going to represent the solution as both a number line and an interval. For the most part, solving a linear inequality is just like solving a linear equation. Your goal is to isolate the variable, and your moves are pretty much the same as before. Whatever you do on one side, you do on the other. Now, there are a few exceptions, which we will talk about in subsequent videos, hence the part 1. But how can we solve 7x plus 1 is less than or equal to negative 10? The answer is the same way we would solve it if it said equals. Start by subtracting 1 from both sides. That would cancel the ones on the left, leaving 7x less than or equal to negative 10 minus 1. When you combine two negatives, you get a bigger negative. Negative 10 minus 1 is negative 11. And then to finish isolating the variable, divide both sides of the inequality by 7 to cancel the 7's, leaving the variable by itself. So we have x is less than or equal to. And now we have an inconvenient fraction. Negative 11 sevenths will not reduce, it will not divide, it's just going to sit there and mock you. Not really. It's not an animate object. It can't do things like mock you. You might be panicking about the fraction, but don't. It showed up at the end, we didn't have to do anything with it. Well, sort of. To sketch this solution as a number line, we have to locate negative 11 sevenths on the number line. There's a myth that 0 must belong in the middle of the number line. I reinforced that myth in the previous video. But the truth is, if you're only looking for a single number, just a single number on the number line, you can put it anywhere you want. I choose the middle. It's only when you put more than one number on a number line where you have to be careful. So negative 11 sevenths goes in the middle. Where would I shade? Since it says less than, I shade to the left. But what about at the negative 11 sevenths? Bracket or parentheses? Because it says or equal to, that includes negative 11 sevenths in the solution, so we use a bracket. That was easy. So what's the interval? From left to right, how far does this go to the left? Forever, which means negative infinity, because it's to the left, comma, and clearly it goes to negative 11 sevenths on the right. We've already decided that the negative 11 sevenths gets a bracket, and infinities always get parentheses. That was pretty easy, I think. Let's try the second one. Oh no, there's a fraction. Everybody run away with your hands in the air screaming. No, don't do that, don't do that. The trick to overcoming fractions is to not look at them as fractions, but as division problems. Let me rephrase that. When you're solving an equation, one trick to dealing with fractions is to view them as division problems. To me, this says 5x minus 1, all divided by 2 is greater than 17. So what's the advantage to looking at this as a division problem? Well, if I want to undo a division problem, what's the opposite of dividing? Multiplying. So I would recommend as the first move on this inequality to multiply both sides of the inequality by 2. That will give you the opportunity to cross out the 2's, and now it is not a fraction. We have 5x minus 1 is greater than 17 times 2 is 34. And you can almost put it on autopilot from this point forward. Add 1 to both sides, 1's cancel, we get 5x is greater than 35. Then divide both sides by 5, the 5's cancel, we get x is greater than 35. So what's the number line? Well, first off, find 35. This is a perfect example of not wanting to start at 0. there's a good place for 35. We want the numbers greater than 35, so that's shaded to the right. But we don't include the 35 because the inequality is greater than, not greater than or equal to. Since we don't include the 35, we use parentheses on it, opening towards the shaded part. And so the interval from left to right begins at 35, comma, ends at infinity. Infinities always get parentheses, and in this case, so does the 35. So as you can tell, solving some linear inequalities is pretty straightforward and pretty easy, even if a fraction shows up at the end, or even if there happens to be a fraction at the beginning. So why is this a part one? Well, because I haven't told you the whole story yet. Want to see more? Watch part two.